Chapter 9.2 has a residual plot exercise in the exercises in the book, and I wanted to talk about that. Your instructions say to find the equation of the regression line, construct a scatter plot, and draw the regression line. After you do that, to construct a residual plot and determine if there are any patterns in the residual plot. And here's what you have to do to do this problem. This is the data you're given, so here's X and here's Y. And if you'll go to Tools for Success in My Stat Lab, you'll find where it tells you how to actually do this scatter plot, or you can just graph it by hand. Do a regular XY axis, go over 8, up 18, go over 4, up 11, over 15, up 29, and so on, and just graph the points and then make a line of best fit. So once you do that, and you know what your line of best fit is, you'll find out that the slope of the line is 1.711. Now you know your calculator will do all of this, but you'll need to go to Tools for Success in My Stat Lab and look it up under Chapter 9. And I think it starts in Chapter 9.1 and then it goes on to Chapter 9.2. And here's your y-intercept. So you write the equation in the form of y equals mx plus b. So and you call this equation y hat. So it's 1.711 is your slope, x plus the y-intercept, which is 3.912. Well, that's just finding the regression line, or the line of best fit for the data. So what you do from there is you're going to make a table, and you're going to use the same x's that you already have, which are 8, 4, 15, 7, 6, 3, 12, 10, and 5. Here are your y's, and once you do that, you're going to substitute x, that 8, into this equation. So you'll say 1.711 times 8, and when you get that answer, you're going to add 3.912 to it. So when I multiply 1.711 times times 8, I'm going to get 13.688, and I'm going to add 3.912 to it, and that gives me the 17.6. Then what you do is you will take the equation again, and this time you're going to plug 4 in for x because you're using these x values. So I'm going to say one more time, I'm going to say 1.711 times 4, and when I multiply that, I get 6.844, and I'm going to add 3.912 to it, and that gives me the 10.756. So I'll do each one of those. You don't really need the y, but that came from the first part of the problem. So you just substitute each one of these x values into that equation and then add the y-intercept to it. So you'll go ahead and get all of your answers. Now you're going to need the y, so I need to erase that. I didn't need the y in my essential part, but now I do need y, because my next step is I have to take y, which is 18, and subtract 17.600 from it, and you'll get 0.400. Then I'm going to take 11 and subtract 10.756 from it, and you get 0.244. Then take 29 and subtract this, and because it's a bigger number, it's going to become a negative number. So the point of all of this is you're trying to find out these variables, and then you're going to take those variables with this coordinate with the original x, and I'm going to graph these ordered pairs. So once I graph those ordered pairs, and my x is going to be 8, my y is going to be very, very small, very close to 0. X is going to be 4, this number is close to 0. X is 15, this number is close to 0. So what you do is you graph all of them, and you find out that they hover